And here, e to negative 3 equals x. These are positive numbers, definitely both true. E to the third is positive, and e to negative 3 is 1 over e to the third. Both positive, both in the domain. And the equation has two solutions. Is this okay?
Yep.
Good. So let's choose.
Can we do 101, the one where the bases aren't similar?
101. In 101 we have 5 raised to x squared minus 12, and the other side 25 raised to 2x. Perfect. What type of equation is it? Remember, we always ask ourselves what type of equation is it so we know how to proceed.
Rational?
So let's identify, if I have 1 over x, this is rational. Right? Something over... Indeed.
Because there's an x in the exponent.
Exactly. Awesome. It is exponential. The left-hand side has 5. I can't do anything because 5 cannot be presented in any other way. But here I see 25. And I'm asking myself immediately, can I present it with this base? If I can present 25 with this base, then it's going to be easier moving forward. So is there a way of writing 25 with a base of 5? If there isn't, then I have to proceed.
It would be 5 squared, right?
Excellent. So then this is 5 squared, everything raised to 2x. The left-hand side is 5 raised to x squared minus 12, and the right-hand side, I copy the base. What happens to the exponents now?
They multiply.
Excellent.
Multiply each other.
And now I'm back to the previous situation that I remind you of a few minutes ago. Exponential, exponential, same base, what has to happen to the exponents?
They have to equal each other.
That's it. So in this case, two numbers are equal, they have the same base, their exponents. This is the one-to-one property of the exponential function. So I can't find another. So x squared minus 4x minus 12 equals 0. I'm always hoping for easy factoring. We forgot to state domain. And your answer should be, we didn't forget. This is not a log equation. We don't state domain on exponential equations.
No, only on log equations. Okay.
Only log is a problem. We have 3 problems that we looked at. We have the square root, which is a problem. We have 1 over x, which is a problem. And we have log, which is a problem. These are our problems. Exponential is not a problem ever. It's nicely defined everywhere. So whatever we get, they must work.
X plus 2, x minus 6.
X plus 2, x minus 6, x equals negative 2, x equals 6. And that's it. Very good pick. Anything else?
I feel like we covered one of everything. I'm trying to see if there's anything else in the questions that we haven't.
You want to open my lab math and see if you find anything there that you would like to work on together?
True. my math lab homework always likes to throw really random curveballs.
Okay,
Let's see.
so let's work on that.
That one's just a power and base.
Anything you can find that you would like to work with? No.
Here's a really big one. I guess, I don't know, maybe it's already an exponential. It says, solve the following exponential equation by expressing each side as a power of the same base
Yes.
and then equating exponents. And it has 9 raised to 2x minus 1 equals 729.
Excellent. Good. So this is a what type of equation? And do we have to state the domain or any problems with this?
It just wants the solution set.
Right. So, but there are no problems here. How come? It's exponential. It's not log, correct? Right? We don't have to state any restrictions. Perfect. Okay, so at this point, what we can do is look at this number. I see here 9. Yes, 9 could be written as 3 squared, but I don't really know much about this 729. Now, I prefer having prime numbers as base, but other numbers work as well. So first I'll try to see if 729 is a multiple of 9. I meant to say if 729 is the power of 9. So I'll take 729 and I'll divide by 9. And I get 81. If I didn't divide by 9 again, I get another 9. So this is 9 to the third. So let's take 9 again to make sure. Caret 3, and we get 729. If that's the case, the problem is quite easy, right? What is the next step then?
Setting 2x minus 1, 2, 3. Setting the exponents to each other.
So 2x equals 4, x equals 2, and it's done. They look very weird or difficult or cumbersome initially, but once you sit down and you start working on it, then you realize what's happening here.
So the answer would be x equals 2, right?
Correct? You can always go back and check. 2 times 3
It
is...
wants us to set it to the solution set. Well, what the solution set is.
That's
I
it.
said x equals 2, and it says that's...
They may ask you to put it like this, so you just put 2.
Oh, okay, maybe.
Yeah.
I spend half the time trying to... Yeah, they just wanted 2. I'm so used to trying to write x equals 2 because it sets it wrong when it's...
All right, that's really all I need. So I don't really care what you put in, right, on the test. I will still look at your notes and I will still make the correction. I don't care what you really put in there. You can put 0 for the entire test. What is important to me is what you wrote on paper.
See if I can find a more... Oh, here, I bet you they have word problems in this.
Please do. Please do. You see my point, right?
Mm-hmm.
I don't care. If on the next test and the final you decide to put 0 everywhere, it's fine by me. It doesn't matter. I still look at what you wrote and your work. That's what matters to me.
So this one's talking about the formula A equals P E raised
Yes,
to
remember
R.
we have this R over N raised to NT, or A equals P E to RT. So we discussed these formulas when we started this chapter. This is when the interest is compounded N times per year. This formula is when the interest is compounded continuously. Continuously compounded interest.
Alright, so the question says, Complete the table for a savings account subject to continuous compounding. So we'd use the second one. And it says the total amount invested is $9,500. The annual rate is 11%. And then it says the accumulated amount is double the amount it invested, and it wants to know time t in years.
Excellent. Very good. So, we're told that we deposit a principal of $9,500. The interest rate, please do not ever use percent. It has to be in decimals, a decimal number. So we have R, which is 0.11. We do not have T, because we don't have that. And the accumulated value, we are told, is double the amount we started with. Does this come from 4.4 or 4.5?
This is the homework for 4.4.
Excellent, very good. Because this should be more in 4.5, but it's fine. Okay, so the accumulated value will be replaced by 2 times 9,500. The principal will be replaced by 9,500. Then E is our friendly E. R is given to us as 0.11 times T. Good, we are solving for T. Obviously, I'm going to clean it up, dividing both sides by 9,500. I don't need it. So 2 equals E to 0.11 T. Perfect. The base here is E, the base here is 2. There is no way I can present both sides with the same base. No such thing. We do have an option, an alternative, a way of solving this, even if E and 2 cannot be presented with the same base. And what is that procedure that we need to apply to both sides? What do we apply to both sides? The inverse function. What is the inverse function of an exponential function? The inverse function of exponential is
The natural log.
when I cannot make them with the same base, I apply natural log. Can I apply natural log here and still get the same answer? Of course. But there is no need. This is easier because I can make this as 9 to the third and then it's done. Can I apply natural log? Yes, I'll get the same thing. But here there is no way I can. The left-hand side stays at natural log 2. The other side, I apply a property of natural log that allows me to put 0.11 t in front. I should write times natural log e. How come I don't write it? Let's say we forgot. Let's plug in natural log. So natural log e. E alone without a power is right here, the division symbol with the second key. Division symbol with the second key. Second and E, right? Close the parenthesis. And tell me what you get when you press enter.
1.
That's it. That's why I don't even have to bother with it. It's 1. So therefore, t is this over this. This fancy number natural log 2 over 0.11. So put natural log, oops, clear. Natural log 2, close the parenthesis and divide by 0.11. And we get 6.3. What is 6.3? Measurement unit.
Years.
Excellent. So 6.3 years are needed to double our investment, assuming the interest rate per year, the annual interest rate is 11%. It takes 6.3 years to double our investment. Any questions?
Can we do one where
Yes, of course.
instead of compounding like continuously, it's the specific one?
Absolutely, yes.
Okay, so it says to complete the table for a savings account subject to 360 compoundings yearly.
300,
And 60.
what's 360?
They're too
Compounding.
fast.
Oh, sorry. It says complete the table for a savings account subject to 360 compoundings yearly, and then it has the equation, and then it says amount invested is $1,000. The number of compounding periods is 360.
Oh, okay, okay.
Yeah, and the annual interest rate is 6.1, and then the accumulated amount is 1,200, and it wants us to solve for the time it takes to get there. For T.
The accumulated amount, I'm sorry, one more time. 1,000.
1,200.
Very good. Very good. Okay, so here we are, this time the formula is the other model, which will be given to you. We are given the accumulated value, which is 1,200. We are given the principal, which is 1,000. We are given R, which is 0.061. We are given the number of compounds, 360. And we are given N, which is 360 times T. Same question as before. We're asked to determine T. Any questions so far? I will try to simplify as much as I can. I will not perform this operation. I want it exact, like as is. But I will definitely divide both sides by 1,000. So I will get on the left-hand side 1.2 equals 1 plus 0.061 over 360 raised to 360t. Okay, next step. I just don't get bothered by this. This is just a number. So I have 1.2 equals a number raised to a power. This number and 1.2 cannot be presented with the same base. What should I do? What should I apply to both sides to finally get t?
Natural log.
Exactly. Once you get one or two problems like this, you will see they're all the same. All the same. Natural log 1.2 equals 360t, because it will allow us to put the power in front, times the natural log of this number. Leave it as is. What should I do now to both sides to get t by itself? And that's the final step before I plug it in the calculator.
Divide by.
So divide this piece, right, natural log 1.2, by this and this. 360 natural log 1 plus 0.061 over 360. Do we see this? So let's plug it in the graphing calculator now. S is, be very careful how you plug it in. The numerator is just one term, it does not need parentheses. But the denominator needs all the parentheses it's ready for. In other words, I need a parenthesis here, not a bracket, you know what I mean, a parenthesis here, just for plugging in the graphing calculator. So the numerator, natural log 1.2, close the parenthesis for the log. Divide by, in parentheses, 360, natural log, as you see it already pops up with a parenthesis, 1 plus 0.061 divided by 360. Now you have to close the parenthesis for the log, and you have to close the other parenthesis. Are we okay with this?
My mic is off. I got it.
Is this okay?
Yeah, I feel like this is where I mess up most of it, typing it into the calculator and not putting the parentheses where I need to.
Good. So be careful with that. So press enter. So we have 2.989.
There's no someone else joined us.
I saw Blue is here with us, yes. Okay, so measurement unit for this.
Years.
That's it. To be exact, roughly 3 years.
I think those were some of the most intimidating ones on the homework.
As you see, there is,
intimidating looking.
yeah, it's looking, but you understand it's not a big deal, right?
Yeah.
Once you see it once
It's
or
easier to apply the natural log than it is to try and find a similar thing.
yes, that's true
to
too.
the other ones.
I agree.
You don't have to find a domain or anything.
Yes, because it's exponential. Yeah, we don't have any worries about the exponential. Okay, so we have 5 minutes because I have to get ready for the other class, otherwise I will spend the entire night with you. But let's choose something else for 5 minutes.
You can pick one, Larson.
What was the range between them again?
Oh, yeah, no, right now I think we're picking from MyLab Math. I don't think we are picking anything from the book at this point.
Oh, well then.
I can find another one if you want.
Yes, please.
Alright, so this one, well, it says question 13 for me. I don't know if it'll be different. It says, solve the log equation. Be sure to reject any value of x that is not in the domain.
Yes.
The original log.
Yes.
Get the exact answer. So it says log parentheses 6x minus 5 equals log parentheses x plus 3 close parentheses plus log 7.
Excellent. So we have 2 restrictions to state. What do I write for the first one?
6x minus 5 is greater than 0.
And for the other one, the x plus 3 greater than 0. This one is x greater than 5 over 6, and this is greater than negative 3. Now we can picture what's happening here.
I suppose 5 over 6 to infinity. be the domain.
Excellent. The common domain is indeed 5, 6 to infinity. Perfect. And now let's condense. The right-hand side, the left-hand side is log 6x minus 5, and the right-hand side is?
Log 7 times x minus 3.
I think you
Plus,
gave me
sorry.
oh yeah, that's it. Good.
Okay.
The next step, very clear. Next step.
Distribute
So
7.
yes, but I can distribute it after I get rid of this step. So how do I continue? What is the next step here? I have two numbers, they have the same log, same base. What has to happen to this piece and this piece?
Oh, they equal each other.
That's it.
Yeah.
I bring 7 to the other side, 7x here, so I have negative x. And I bring 5 to the other side, and I have 26. And then x equals negative 26.
So no solution?
That's it.